Hello and welcome to students and parents. My name is Vincent and today I'll be going through the OC placement test for the thinking skills paper. Now I understand that this will be the very first year that thinking skills will be in the OC test, replacing the old general ability questions. And most students will be seeing these styles of questions for the very first time. Not to worry though, because today I'll be discussing not only the solutions to each question of this paper, but also I'll take the time to explain the different categories of questions that you might encounter and the fastest and most efficient way of approaching these questions. And some of these methods we've been teaching to our Year 6 students at Alpha 1 who just recently sat the new selective test where they also had the thinking skills section. Anyways, let's get into the questions and I hope you enjoy the explanations and find them useful. Okay, so starting off with question 1, we see that a slow train departed from Lode at 1 p.m. and arrived at Braxton at 7 p.m. An express train departed from Lode later and arrived at Braxton at the same time as the slow train. The express train was 4 times as fast as the slow train. Each train traveled at a constant speed and did not stop along the way. When did the express train depart from Lode? So for this very first style question, this falls into the category of a problem-solving question. So just write that here, problem-solving style of question. And these styles of questions are more mathematically based. And so generally they test whether you can solve a word problem using some sort of mathematical operation. It might be something like fractions, or in this case, knowing how to solve a distance, speed, time sort of question. So when we approach these styles of questions, it's important to underline the key information. So we understand that there is a slow train that leaves Lode at 1 p.m. and arrives Braxton at 7. So that means that the slow train had a journey or a duration of 6 hours from 1 o'clock to 7 o'clock. So we'll just write time was 6 hours. Yeah. And then we find out that the express train, leaves later, but arrives at the same time. And then most importantly, it was 4 times as fast. So let's now write the express train down here. Now, think of it this way. If the express train is 4 times as fast, then the time of its journey should be 4 times quicker, right? So if the slow train took 6 hours to complete the journey, the express train should have done that in 1/4 of that time, right? And so we should write then that the time it takes would be 6 hours divided by 4, so 1/4 of 6. All right, so I'm just going to write that as 6/4, which we know can be simplified to 3/2 if we divide the top and bottom both by 2, right? And it becomes 3/2. So 3/2 hours, that's 1.5 hours. So now we just simply work backwards. We know that the express train arrived at Braxton at the same time as the slow train. So this statement over here. So the slow train arrived at Braxton at 7 p.m. And since the express train only takes 1.5 hours to do that journey, if we just count backwards by 1.5 hours, we get an answer of 5:30 p.m. And that gives us the answer of D. Okay, moving on to question 2. A health specialist has suggested that dance lessons should be an important part of school life and that school children should spend as much time learning to dance as they do playing sport. Which of these statements, if true, best supports the health specialist's claim? So as you can already quickly see, this is a very different style of question compared to question 1. And this style is known as critical thinking style of question. And it primarily tests the students' language abilities, such as their command of vocabulary, as well as their ability to think critically and logically. There's actually 5 different types of critical thinking questions, and this particular type is known as assessing the impact of additional evidence. Okay, so as you can see, they give you a paragraph that has a certain argument or draws a certain conclusion. And from that, you have to now choose from the answer options a statement that either best supports the above conclusion or argument or weakens the above conclusion argument. In this case, we're looking for a statement that supports the health specialist's claim, which is the argument or conclusion of this paragraph. So that actually is the first step. The first step in doing this style of critical thinking question is to read through the paragraph and find out what is it trying to argue or what conclusion is it trying to get you to agree on. Okay, so that's step 1. I'll write that over here. So step 1, you need to identify the argument and its conclusion. Once you have a good idea of what it's trying to argue or conclude, then you can move on to step 2, which is simply find a statement that supports the conclusion. So you need to read through the options to find the answer that best supports the conclusion. Okay. In this case, it supports since the question is asking for the one that best supports. So let's run through this method with this question. We need to first read through the paragraph and then identify the argument. Well, basically, there's a health specialist who suggested, so he's trying to convince us that dance lessons should be an important part of school life. So I'll underline that bit because that is pretty much the arguments in this paragraph. And then he was saying, or this health specialist is saying, that we need to spend as much time learning to dance as we do playing sport because it's an important part of school life. So now if you move through to step 2, we basically should be looking for a statement that's saying dance is great. A statement that would say, this is the benefit of dancing, and that's why it's very important. Right, so we should be looking for a statement that provides a reason that dance lessons should be an important part of life. Okay, so having that go through your head is good before you actually read through the options, because sometimes the options can try and confuse you deliberately. So if we read through A, then it says dancing improves children's mental abilities. Option A seems pretty good at the moment, doesn't it? Because it's basically saying that dancing has this great benefit of improving a child's mental ability. So what we'll do is we'll just place a tick here for now. I won't choose the answer straight away because you need to look through all the options for these types of questions, since you're trying to find a statement that best supports the claim or best supports the argument or the conclusion of the paragraph. So B, C, and D there might be even a better option than A in the last 3, right? So we have to read through all of them, okay? So B says, some children cannot afford equipment to participate in sports. So it doesn't really mention the word dance at all, right? It's not arguing that dance is great, has these benefits. It's simply saying that some children can't afford the equipment that you need to play sports. So it does not really explicitly support that dance is great. So in that view, I will draw a cross through B. Okay. Moving on to option C. C says some children dream of becoming professional sports people. Again, the focus of C is saying some kids dream of becoming a sportsman or an athlete, right? And really has nothing to do with dance again. In fact, it's kind of doing the opposite. It's saying C would be trying to support the fact that, sport is great and everyone should try and dream of, all these kids should dream of becoming a professional athlete. So again, I crossed through C because it actually does the opposite. It's supporting sports instead of dance. And then lastly, we have D. D says dancing has been taught in schools in the past. So good thing about D is that it's actually talking about dancing, which is relevant to the argument of our paragraph. But it's just making a neutral statement. It's saying that dancing has been taught in the past in schools. It's not really saying dancing's great. It's not really either saying dancing's bad. It's just a very neutral statement. So for that, I just draw a dash because it's quite neutral. It's not really supporting the fact that dancing is an important part of school life. So after looking through all these options, right, it's pretty clear that the answer option that we should be choosing is A here, since it actually provides a statement that supports why dancing is important. In this case, improves a child's mental ability. Okay, let's move on to question 3. So in question 3, let's have a read of it. It says, Alex, Ben, and Carlos all keep pets. Alex has snakes, fish, lizards, rats, and frogs. Ben keeps cats, frogs, and rats. Carlos keeps fish, parrots, rats, grasshoppers, and frogs. When we read through the question, it's asking us, which pets does Alex keep that neither Ben nor Carlos keep? So again, I would classify this as a problem-solving question. And in this case, this type of problem solving is known as finding procedures. There's many different ways of doing this question, but it's often about, the trick is to find the most efficient and fastest way of doing it. So for this type of question, I recommend doing the elimination method. Right? Because the question is asking us, what pets does Alex keep that neither Ben nor Carlos keep? What I would do is I'll read through Ben's animals. So Ben keeps cats. So then I'll quickly look at what Alex has, and he doesn't have any cats, so we don't have to, there's no overlap there. Then we see that Ben keeps frogs, and we see Alex keeps frogs as well, right? So we can cross out frogs from Alex's list there, since Ben also has that. And then Ben also has rats, and Alex has rats too. So I'll cross out rats because they both have those animals. Then we move on to Carlos. Carlos keeps fish. Again, Alex has fish as well, so we'll cross that out. And Carlos keeps parrots. There's no parrots. He keeps rats. We've already crossed out rats. Grasshoppers. Alex doesn't have any grasshoppers. And frogs, which we have already crossed out. So the remaining two animals that Alex has that neither Ben or Carlos keep is snakes and lizards, which gives us the answer of D. Cool. Let's now move on to question 4. All right, just reading through question 4 now. Next year at school, I need to choose 4 subjects to study. I have to choose one subject from each of the following lists. And then moving down here, it says, I know that I want to study English, history, and science. Which one of the following can I not choose as my final subject? So again, this is a type of problem-solving question. And with this one, we just need to figure out the fastest way of approaching it. And in this case, it would be to first identify where English, history, and science appear in the lists. Okay, so we see that history appears in list 1, and that's all that it appears in. It does not come again in list 2, 3, or 4. Then we move on to English. For English, we see that it appears in list 2 as well as list 3. And lastly, science, we know that it appears in list 3 as well as list 4. So from doing this, the most important thing you can take away is that history only appears in list 1, whereas English and science both appear twice. English appears in list 2 and 3, and science appears in list 3 and 4. And what that means is I have to choose from list 1 history, right? Because it does not appear anywhere else. So if I want to study history, I will have to choose it for list 1, which means I won't be able to choose arts or geography or PE from list 1. Okay, and if you look at our answer options, A is arts, B is geography, and D is PE. Right, health it doesn't appear, right? So we know that we won't be able to choose arts, geography, or PE since history has to be the one we choose in list 1. What we now need to do is look whether arts, geography, or PE occur elsewhere so that we can choose them in the other lists, right? So if you start off with arts, you notice that arts does not appear in list 2 3, or 4, which means we won't be able to choose arts if we have to choose history in list 1. All right, let's just confirm that that is the answer. If you look at geography, it appears here. If you look at PE, it appears in list 4 as well, which means that we will have a chance to choose those subjects in the other lists, even if we choose history for list 1. Okay, so remember the key here is finding the most efficient method, and that's the one I've just discussed. All right, so because we have to choose history for list 1, which that means arts won't be able to choose, we can't choose arts, and arts does not occur in any of the other lists, so therefore we definitely can't choose arts as my final subject, and that gives us the answer of A. Moving on to question 5. Okay, so moving on to question 4, we have next year at school, I need to choose 4 subjects to study. I have to choose one subject from each of the following lists. And you can see there's 4 lists, each with 4 different subjects. And it says, I know that I want to study English, history, and science. So underline those. Which one of the following can I not choose as my final subject? Okay, so again, this is a type of problem-solving question. And again, it's a finding procedures type of problem-solving question, because you have many different ways of approaching this question, but you need to choose the quickest and most efficient way to do it. And that's what we'll go through right now. So the first step here would be to actually find from the lists the subjects that you want to study, right? Because we need to figure out which ones we're going to choose from which list. So we see that history is in list 1, so we'll circle that. And we see that English actually occurs in both list 2 and list 3, and science occurs in list 3 and list 4. So a very important thing to take away right now is the fact that history only appears once. It only appears in list 1. So I'll write that there. Whereas English and science both occur twice. So English occurs in list 2 and 3. Science occurs in both list 3 and 4. Okay, and that's really important because since we want to study history and it only appears in list 1, we have to choose history as the subject from list 1, right? We have to, which means that we'll have to miss out on the other 3 subjects from list 1, which is arts, geography, and PE. Now, remember the question is asking us, which one of the following can I not choose as my final subject, right? And out of the answer options, we can see that there's arts, there's geography, and there's also PE, right? So immediately, what I'm thinking is, since I have to choose history on list 1, it means I'll have to miss out on arts, geography, and PE unless those subjects occur in one of the other 3 lists. So that's what we're going to do now. So you look at arts. Does it appear in list 2, 3, or 4? And the answer is no, it doesn't. Arts only appears in list 1. And the fact that we have to choose history for list 1 means we'll never be able to choose arts again, right? So art is looking like a pretty strong answer at the moment, but you want to just confirm that this is true. So looking at geography now, can you find geography in any of the other lists, 2, 3, and 4? Yes, you can, right? So geography, I just draw a star, occurs here. And what about PE? Yes, PE also occurs in list 4, which means even though I might miss out on it in list 1, I'll be able to choose it again from one of the other lists. So that to me is confirmation enough that arts is the only subject that I can't choose as my final subject. And the reason again is in list 1, you must choose history since you want to study history and it doesn't occur anywhere else. And that means you have to miss out on arts since it doesn't occur in any of the other lists. Great stuff. Let's now move on to question 5. Okay, so in question 5, we have only those students who attend the meeting at lunchtime today will be allowed to go on the excursion to the museum next week. And then we have 2 different statements from Mia and Tyler. Mia says, Jaden is going to the meeting today, so he'll definitely be able to go on the excursion. I'll just circle definitely. It's a very important keyword, and I'll discuss why that is later. And then let's move on to Tyler's statement. Noah's going to cricket practice at lunchtime today, so he won't be able to go on the excursion. If the information in the box is true, whose reasoning is correct? All right, so let's break down this new type of question. This is a critical thinking question. And this time the style is called detecting reasoning errors. And as the name suggests, your job is to find if there's any error in either Mia's or Tyler's reasoning. And this type of question can be quite tricky at first because it's very easy to make assumptions. And that's where most of the students commonly get trapped into making a mistake because it's, without the experience and practice, you might just easily make that assumption. Okay. But bear in mind, once you see the different types of detecting reasoning error questions and you get enough experience with them, you'll pick up on the fact that they all kind of work on the same concept. And once you understand that concept, these types of questions actually become quite easy. Okay, so let's actually go through the approach to doing these questions so that you won't make a common assumption and get the question wrong. So for this one, the step 1 is to avoid making any, and when I say any, I do mean any assumption outside of what is true in the box given above, right? So the way I like to break it down is the information that's in this box, you treat this like the law, or this, whatever's said in this box is the only truth that exists, right? Outside of that, nothing else you can assume to be true, right? It's like the law, it's like the Bible, okay? You can't assume anything outside of that box to be true. So let's just read through that box again. It says only those students who attend the lunchtime meeting will be allowed, and that's an important keyword, to go on the museum excursion next week. All right, so only students who go to the lunchtime meeting, they will be allowed to go to the excursion. So a very key thing to keep in mind is this statement, or this true statement in the box, is stating students who go to the meeting will be allowed to go to the excursion. This doesn't mean that students who attend the meeting will definitely go to the excursion. right? There's a key difference. One saying you can be allowed, and what Mia's saying is that if you go to the meeting, Jaden's gone to the meeting, he'll definitely be able to go to the excursion. No, that can't be true because you can be allowed, like if you, let's say you attended the meeting today, means you're allowed to go to excursion, but there could be multiple reasons why you might not make it. You might fall sick on the day of the excursion. You might miss the bus on the day of the excursion. So even though you attended the meeting, there is a chance, even though you're allowed to go to the excursion, there's a chance that you might not make it. So that's an error in Mia's reasoning to say that if you go to the meeting today, you'll definitely go on the excursion, because definitely implies 100% of the time. It's a very powerful absolute statement, right? And again, Mia's kind of made this assumption. Just because you're allowed to do the excursion doesn't mean you'll definitely be on the excursion. So in that case, we have to say that Mia's statement or Mia's reasoning is incorrect, right? Then we move on to Tyler's statement. So Tyler's kind of saying the opposite, saying that Noah, is going to cricket practice today. So which means he won't be able to make the meeting since he's going to be at cricket practice. And you know that if you don't go to the meeting, you won't be allowed to go on the excursion. So you can assume that to be true. It's just the opposite of this true statement given in the box. So if you don't attend meeting, you won't be allowed on the excursion. And we know that's true because in the statement or the law that's stated in the box, it says only the students who attend will be allowed. So that implies that if you don't attend, you won't be allowed, right? So that is an assumption. It's not really an assumption. That's a logical deduction that you can make from the statement in the box, right? Since the word only will imply those students who don't go to the meeting won't be allowed. And based on that, right, Tyler's reasoning makes sense, right? So Noah is going to miss the meeting since he has cricket practice at the same time at lunchtime. So therefore, he won't be allowed to go on the excursion. We have to give Tyler's statement a big tick. So based on that, the answer option that's correct has to be B, Tyler only. And just going back to our step 2 would be to evaluate the given statements by Mia and Tyler. So evaluate their statements against the truth in the box. Right. So the really important thing to take away from detecting reasoning error questions, to recap, guys, is you have to assume the only thing you can assume to be true is what's given to you in the box. Anything outside of that, you can't assume anything. Okay, this is the only thing you can assume to be true, what's said in the box. Okay, so let me just emphasize that this statement is the only thing you can assume to be true. You can think of it like gravity. No matter where you are in the world, gravity is gonna exist. And it's gonna be true. Excellent. Let's now move on to question 6. All right, so for question 6, we have Archie, Bo, and Carter are standing in a row, if Archie is to the right of Bo and Carter is to the left of Archie, which one of the following statements must be true? So again, this is a type of problem-solving question. Again, it's a finding procedure one because they will give you various information in words, and you have to come up with a way that solves the question the fastest, right? And the fastest method for this type of question, you'll see it quite often actually. The other examples are like people are waiting in a queue for a movie, and then they tell you, certain rules about who's waiting in which part of the line, or it might be you might have seen a question like 5 people live in a row of houses on the same street, and then they give you different rules as to who's living in which house. But it's all the same concept, right? You're lining people or things in a row. And the best way of doing those questions is to draw a diagram. Okay, and that's exactly what we're going to do. So we're going to draw a diagram. That is the first step. It's actually the one and only step you need for this. So I'll start off by just clarifying where left and right is so we don't get confused. So left's here and then right is going to be here. And then I just slowly make my way through the information that's given or the rules that are given and update my diagram accordingly. So we first read that Archie is to the right of Bo. So what I'm going to do is I'm going to write A for Archie. A, and Archie is going to be on the right of Bo. So Bo is going to be here for now. Okay. And now let's move on to the second part of the rule. It says that Carter is to the left of Archie. Okay. So if Carter is to the left of Archie, here is where we have to consider 2 scenarios. So Carter could be immediately on the left of Archie. So I'll just draw an arrow and write C for Carter. Carter could be just immediately on the left of Archie, or Carter could be, I guess, a bit more to the left of both Archie and Bo. So Carter could also be in this position. We call that position 2. Okay, so based on the information that's given, that Carter's to the left of Archie, we can't actually say exactly where he is because the statement is not specific enough, right? So in that case, you can't just be like, okay, I'm going to take a guess and I'm going to put Carter right in between the middle of Archie and Bo. You can't do that. That would just be making an assumption, right? You have to consider both scenarios because there's not enough information given. Okay, so that's as much as we can update our diagram. And after that, I'll start going through the options and seeing which ones we can rule out and which one must be the true statement. Okay, so reading through option A, it says Bo is furthest to the right. So you can see obviously that Archie would be the furthest to the right, regardless of where Carter stands. All right, Archie will be the furthest to the right. So A is definitely incorrect. We can cross that out. B, Carter says Carter is furthest to the left. Now, that could or that might be true if scenario 2 occurs and Carter is standing, the furthest to the left of both Archie and Bo, then Carter would be furthest to the left. But in scenario 1, Carter will be in the middle of Archie and Bo. And so because of that, because you don't know exactly where Carter's going to stand, you can't say B must be true. B might be true, but we're looking for a statement that must be true. And because of that, we can't accept B either, okay? It's not an absolutely true statement. C, Archie is in the middle. We've already established that Archie is the furthest on the right, so Archie will never be in the middle. So C is incorrect. We can cross that out. And that gives us D. So let's just make sure D is correct. It says Archie is furthest to the right, and that's something we've already established. Archie is indeed the furthest to the right in our diagram. So D must be our correct answer. Awesome. Let's keep on going to question 7. Alrighty, so in question 7 it says, a show is to be performed from Wednesday the 12th to Saturday the 29th of the same month. So just circle those dates, 12th and 29th. There will be a performance every evening. On Wednesdays and Saturdays, there will be an afternoon performance as well. Okay, so there's a performance every evening, but on the special days of Wednesday and Saturday, there's going to be an extra afternoon performance. And the question is asking us, how many performances of the show will there be? So again, this is a type of problem solving question. Again, finding procedures, because there's many different ways of doing this question, right? Many ways of calculating how many show performances there are. There's a very long method where you simply write out the calendar and count every single day that exists between the 12th and the 29th. And, you slowly count your way up to you get all the performances that occur. But that will take a long time, right? So again, we need to make sure we find the quickest and the fastest method of doing this type of question. So the way I would approach this is to draw like a mini part of the calendar that only we're interested in. So we're interested in Wednesdays the 12th through to Saturday the 29th. In particular, the special days Wednesdays and Saturdays. So I'm going to start off by drawing W for Wednesday. And we know that Thursday occurs after that. Then it's Friday. And then it's Saturday, right? And we know the show is going to start on Wednesday the 12th. So I'm going to write 12 here, which means Thursday must be the 13th. Friday must be the 14th. And Saturday must be the 15th. And instead of writing out the rest of the days, Sunday, Monday, Tuesday, there's a bit of a quicker method of finding out how many more Wednesdays there are. So if, it's Wednesday the 12th, the following Wednesday should just be, 7 days later, given that there's, 7 days in 1 week. So the following Wednesday after the 12th must be 12 plus 7, 19. And if we do that again, the Wednesday after that must be 19 plus 7, which is the 26th. Right, and we can do the same thing for the Saturday. So 15th, then it should be the 22nd, and then it should be the 29th. So that's very good, because the 29th just happens to be the last day of this show that's going to be performed. Okay, and just keep in mind, we will have a performance every evening between these 2 dates. So there'll be a performance every evening, but on Wednesdays and Saturdays, there's going to be an extra afternoon performance as well, right? And so we can just quickly on our calendar figure out how many special Wednesdays and Saturdays exist between the 12th and 29th. So I'll just circle them. You can see that there's 6 Wednesdays and Saturdays in total where you have an extra afternoon performance. So step 1 here would just to figure out how many evening performances there are. And to do that, we'll actually need to figure out how many days exist from Wednesday the 12th to Saturday the 29th, right? We have to figure out how many days are there in between 12th and 29th, inclusive. Now to do that, there's a long method, which is to count, 12, 13, 14, 15, and keep on going till the 29th. And then you figure out how many days there are. But again, that takes too long. There's a shortcut method that I'll teach you guys, okay? So we teach this to some of the students in our year 6 students who just sat the selective test. The trick is to actually get the larger number here, or the ending day, 29th, and you minus the starting date, which is the 12th. Okay, this only works, by the way, if it's in the same month, so just keep that in mind. So 29 minus 12, 9 minus 2, that's 7. 2 minus 1, that's 1. So that means, there's 17. Now, here is where a lot of students actually get trapped. You might think, okay, that means there's 17 days from Wednesday the 12th to Saturday the 29th. But no, you actually need to add an extra 1 here, okay? Because it's a bit tricky to explain in words, so I'll show you with an example and make much more sense. But just take my word for now that you'll need to add this extra 1, right? So this is going to be the tip and trick here, okay? You need to add that extra 1, which gives you 18. So there's actually going to be 18 days between Wednesday the 12th and Saturday the 29th. And here's the reason why you need to add 1, all right? Let's take a very simple example. Let's say we were trying to figure out the amount of days between January the 1st to January the 3rd. Okay, so this one you can use the counting method because it won't take too long anyways. How many days exist from Jan 1st to Jan 3rd? Well, there's the 1st of Jan, the 2nd of Jan, and the 3rd of Jan. So that's 3 days, right? Easy. So 3 days. 1 second. Yeah. 3 days in between. Now, if we use that shortcut method I just taught you, we will take the ending day, which is 3, and we will take away the starting date, which is 1, right? And 3 minus 1 gives us 2. Now, we just said there were 3 days from Jan 1st to Jan 3rd. So obviously, it's not 2, right? And so that's why we need to add that extra 1 there, okay? To make sure the answer is consistent. So there you go. With that simple example, hopefully that clarifies why you always need to add an extra 1, okay? So now we know that there are 18 days from Wednesday the 12th to Saturday the 29th inclusive, okay? Which means since there's a performance every evening, that means there will be 18 evening performances, okay? Now we just need to figure out how many extra afternoon performances there are as well. Well, that's pretty easy because we already know there are 3 special Wednesdays and 3 special Saturdays in between this time period. So that's total 6, right? So that means there will be an extra 6 afternoon performances, which gives us a grand total of 24, giving us an answer of D. Excellent. Let's move on to question 8. Now, question 8, let's just read through it. It says, Daryl and Jim are in the corridor. Daryl says, Jane asked me to fetch her jacket, but I can't seem to find it here. It's blue with a hood, she says. And then Jim says, here's a blue jacket with a hood. It must be hers. And again, I'm going to circle the word must because it's a very important keyword in this question. Which one of the following sentences shows the mistake Jim has made? All right, so let's break down this type of question. So this, again, is a critical thinking question. And this style is known as identifying assumptions. Okay, so it's a critical thinking question. And it's identifying assumptions. You'll find that this style of question is really similar to the one we did before called detecting reasoning errors. They're pretty much the same thing, okay? In detecting reasoning errors, you're often also finding any assumptions the person's made. And in this case, we're doing the same thing. We need to find the assumption that Jim has made, okay? And that is all to do with the keyword must, Okay, so the approach is going to be very similar. We know that Jane's lost a jacket, right? And it's blue with a hood. Now, Jim says, here is a blue jacket with a hood. It must be hers. And must implies 100% of the time that this blue jacket with a hood is 100% of the time going to be Jane's. But therein lies the assumption or the mistake that Jim's made. There can be more than one blue jacket with a hood, right? Blue is a very common color. Jackets these days often come with hoods. There's definitely the possibility that there's more than one blue jacket with a hood, right? And so therefore, you can't say for certain that the one blue jacket with a hood that Jim found is absolutely Jane's, right? It could just be another person's blue jacket with a hood. And so that's the assumption that Jim has made. He's assumed that, the blue jacket with a hood that he's found has to be Jane's, when in reality, there could be multiple blue jackets with a hood. And if you look through our answer options, which one is saying that? That's the answer C. All right, there might be more than one blue jacket with a hood. And just to be safe, you just rule out the other options. Okay, so have a quick scan. A says Jane might prefer a different jacket. That's going to be incorrect because it has really nothing to do what Jim's, said, right? Telling me Jane prefers a different jacket is completely irrelevant to what's happening here, right? So we're going to rule that out because it's quite irrelevant to Jim's statement. Then B says Daryl might be looking for someone else's jacket. Again, that's not even true, right? That's incorrect because Daryl is looking for Jane's jacket, right? It's said in this question above, right? That's something we can take to be true. So there's no indication that Daryl was looking for someone else's jacket. So I'm going to label that as incorrect or just false. And lastly, D, even if the jacket is blue, it might not have a hood. Sure, right? Even the jacket's blue, some jackets, some blue jackets might not have a hood. Some blue jackets might have a hood. But the reality of the fact is statement D is quite irrelevant to what Jim has said. Jim has said he is a blue jacket with a hood, right? So it's not really relevant to what Jim is saying. So again, we can cross it out because it's irrelevant. Excellent. Let's keep on going to question 9. Alrighty, question 9 is a style of critical thinking question that we've encountered before. It's the one where we have to assess the impact of additional evidence. So let's have a look through it. It says a police officer says anyone riding a motorcycle should wear a helmet, right? So if you ride a motorcycle, you should wear a helmet. Keyword being should here, okay? Which one of the statements, if true, best supports the police officer's claim, right? Again, we're looking for a statement that supports the police officer's claim. And now, if you remember, the strategy for approaching this style of question, assessing the impact of additional evidence, we need to first figure out what the argument is. Well, the argument is pretty easy this time because it's just simply one statement. It's saying that if you ride a motorcycle, you should wear a helmet, right? So now what you need to think is, before you look at the answer options, is what sort of statement would support that argument? Well, if off the top of my head, I would say any sort of statement that tells you about the benefit of wearing a helmet, how it can protect you, how it can make it safer, right? Or something that says about the dangers of not wearing a helmet. That would also support what this police officer is saying. So, reading through our options then, A says, good helmets are cheaper and lighter than they used to be. Sure, that's a good statement. Like, it's a high quality helmets, it's cheaper, it's lighter than what they used to be maybe a couple of years ago. But is that really relevant to what police officers are saying? Police officers saying you should wear a helmet if you ride a motorcycle. But telling me that good helmets are cheaper, it might seem like it's supporting the police officer's claim, but it's not a very strong support, right? So for that, I just would say it's weakly supporting it. Yeah, and it's more kind of an irrelevant statement at this point in time. Okay, so I just write. I'm gonna draw a dash here and just say weak support. It's not very directly saying, oh yes, you should wear a helmet because it's gonna save your life. It's just saying good helmets are cheaper. Let's move on to option B. You are much less likely to suffer a serious injury if you are wearing a helmet. Now, you can see in this one, it's much more of a direct support for the police officer's claim, right? It's saying that if you wear a helmet, you're going to have a lower chance of getting a serious injury, which definitely supports the statement that if you ride a motorcycle, you should wear a helmet. Okay, so B is looking pretty good at this moment. I'll give it a tick. Seems like a strong support. And even though you might think B is a very good answer at this point, you should still look at C and D because remember, the question is always asking for the best statement that supports it. So, doing that, C says people riding horses normally wear some sort of head protection. Again, I would say that this is quite irrelevant because we're talking about motorcycles here, right? So telling me that people who ride horses wear helmets, it's not really relevant to talking about people riding motorcycles should wear a helmet. It's off topic. And lastly, D, motorcycles can travel a lot faster than bicycles. Okay, that is a true statement, right? Motorcycles do travel a lot faster than bicycles, but is that what we're trying to talk about here? We're trying to focus on motorcycles. Motorcyclists should wear a helmet. We're not trying to compare the speed of a motorcycle to the speed of a bicycle. So again, I'll cross it out because it's quite irrelevant. And so that really does leave us with the answer of B for question 9. Awesome. Let's move on to question 10. Okay, so for question 10, let's have a look through it. It says, on a normal dice, the numbers on each pair of opposite sides add up to 7. Which one of the following that's shown below is the only one which makes a normal dice when folded? So we know the key information here is that each pair of opposite side adds up to 7. So again, this is a problem-solving type of question. And in this case, knowing this specific tip will make your life a lot easier. Otherwise, you'll have to reconstruct all these different cubes. But the alpha tip that I'll give you guys is that opposite sides of a cube on a net diagram are always 2 boxes away from each other if they're in a straight line. Okay, and I'll explain exactly what that means, okay, in a second. So opposite sides of a cube are 2 away from each other. 2 spaces, I should say, 2 spaces away from each other if in a straight line on a net diagram. And if in case you didn't know, the net diagrams are the answer options. It's what a net diagram is what you get when you unfold a particular shape. So in this case, when you unfold a cube, all the different faces lying flat on, on the horizontal surface creates this net diagram that you kind of see in the answer options. And if you fold it back up, it would create a cube. So what is my tip actually saying? It's saying that, let's say, for example, in option A, and we're looking at this particular face, right, which has, 1 dot. I know that the face opposite to this one will be 2 spaces away. So 1, 2. So that would be this face here with the 4 dots. Okay, so I know for a fact that the face with 1 dot should be opposite to the face with the 4 dots when this cube, is created again. Okay, because it's 2 spaces away from each other in a straight line. Now remember, the rule is pairs of opposite sides should add up to 7, right? In this case, this is 1 dot and 4 dots, it adds up to 5, right? So these opposite sides add up to 5, they don't add up to 7, so it can't be a normal dice. Okay, so we can cross out option A. All right, we look at option B. Again, just choose a specific face. You can choose this one here, the one with 2 dots, and just choose a face that's 2 spaces away. So 1 and then 2. So that would be the face with 1 dot, as long as it's in a straight line, guys. Okay, so again, those 2 faces should be opposite, and they add up to 3 dots. So again, that's not 7, so we can cross out B. And then in option D, we can just go to option D. If we just choose any 2 random ones, so this time I'm going to choose this one with 3 dots and 2 spaces away in a straight line. So 1, 2. That would be the face with 5 dots. Again, 3 plus 5 is 8. So that's not 7. So we can cross out D. That leaves us with answer option C. Okay, let's just confirm this is correct. Now, in answer option C, you can see that this net diagram is a bit different. There's not many faces in a straight line. So our tip won't actually work in this case. Yeah, we can't say, okay, just to make it very clear, you can't use this tip like this. You can't be like, okay, I'm going to choose the slide, the face with 6 dots, and I'm going to go 1 space, then 2 spaces, and therefore it's 3 dots, and they're opposite each other. No, that's not true, because that's not in a straight line. You've actually gone across and then down. All right, so that's a big no-no. This alpha tip won't apply unless those faces are in a straight line. Okay, so let's rub that out. For this one, you're going to have to use a bit more of your imagination. Okay. Now, this type of question also tests a bit of visual spatial reasoning. I should mention that. Let me just write it on this side here. Visual spatial reasoning, which simply tests your ability to move 3D and 2D objects in your head in a logical way. So that's why it's testing your sense of space as well as your ability to visualize things in your head. So that's what you're going to need to do for option C. Pretend that you're going to fold this cube up again. Okay, and so what would happen is you can fold these 2 faces up off the screen, so it comes up, and then this face with 1 dot, imagine you folding it this way, folding it up but towards the left. What should happen is the face with this 1 dot will become opposite to the face with the 6 dots after you fold it up. And 1 plus 6 is indeed 7. So therefore, This confirms that our answer should be C. Another good thing to do when you first start off with visual spatial reasoning questions is to actually draw it out on a spare piece of paper, cut it up and fold it up yourself. Because when you actually do it in real life and you see it happening before your eyes, it's much easier to visualize in the future. Awesome. Let's now move on to the next question, 11. So in question 11, it says, when Kinta was learning to drive, his instructor told him to even have a chance of passing your driving test, you must have had at least 20 hours of driving practice. Okay, so this is a type of critical thinking question. Again, it's testing your ability to think logically and critically. And this is, again, a type of question where we're detecting any reasoning errors or whether you make any assumptions. It's actually a bit of both in this one, okay? So there's a bit of overlap. So what the driving instructor is telling Kinta is something that you can assume to be true, right? It's like that statement in that box. So his instructor says to even have a chance, okay? I'll underline that. Have a chance of passing, you must have had at least 20 hours of driving practice. Okay, so notice the words I've underlined. These are very important keywords. One is saying to even have a chance to, like, actually to have like a 1%, 2%, 10% chance of passing. You must remember is that very strong absolute word, which means 100% of the time you need to have at least 20 hours of driving practice. Okay, so if I was to summarize that statement, is to have a chance of passing, you absolutely need to have done more than 20 hours, right? At least 20 hours, which also means the opposite is true. If you do less than 20 hours, that means you'll have 0 chance of passing, right? Because to have a chance of passing, you need to have done at least 20 hours. So if you do less than 20 hours, you should have 0 chance of passing. Okay, so now that we've broken down the statement that we know is true, let's see which of the following statements will be true. Option A says, all the drivers who have had 20 hours or more of practice will pass their test. So option A is saying if you have greater than 20 hours, you will pass. Will is also a strong word. It's suggesting that you will pass, which means 100% of the time, which is not what our statement was saying. Was saying that if you have at least 20 hours, you have a chance. It doesn't say you will absolutely pass the test. So A is definitely incorrect because it's made that assumption that, having a chance means you will pass, right? Which is not what having a chance means. Having a chance could just be a 1% chance of passing. B, none of the learner drivers who have had less than 20 hours of practice will pass the test. So let's break down B. B is saying that if you've had less than 20 hours of practice, right, all those drivers will not pass the test, right? Because it's saying none of those drivers who have less than 20 hours will pass the test, which also means if you have less than 20 hours, you will not pass the test. You'll have 0 chance of passing the test, which is actually the statement here, right? And we already concluded or established that this is a true statement. So B should be our correct answer. Right, if you read through option C and D, again, you'll be able to identify that they've made an assumption or there's an error in their logical reasoning. So moving on now to question 12. Okay, so for question 12, we've got an emu's egg is dark green, speckled with white spots, and can measure up to 13 centimeters long. Only an ostrich's egg is larger. So keyword here is only. Now we have to evaluate Charlotte and Oliver's statements to see whose reasoning is correct. So again, this is that critical thinking skills question where we have to detect reasoning errors. So Charlotte says this egg is dark green and fairly large, so it must be an emu's. And Oliver says, but it's only about 10 centimeters long, so it can't be. So if the information in the box is true, whose reasoning is correct? All right, so just recapping that method that we said, for detecting reasoning questions, the most important thing is to only assume what is written in the box to be true. Anything outside of that box, you cannot assume to be true, okay? So what we know is that an emu's egg, it's dark green, and it can measure up to 13 centimeters long. Measure up to 13 centimeters. Only an ostrich's is larger. So Charlotte then says, this egg is dark green and fairly large, so it must be an emu's. Well, that's quite interesting, isn't it? Because we've just concluded from this statement in the box that, you know, if it's dark green and it's like up to 13 centimeters long, it's an emu's egg. And that if it's any bigger than that, then it has to be an ostrich's. So based on Charlotte's statement, we know that the egg is dark green and it's fairly big, right? So she's made such a quite a general statement. So it could be an emu's, but it could also be an ostrich's, right? Based on the statement in the box. So Charlotte's statement or Charlotte's reasoning is incorrect because she's assumed this egg to only be an emu's when in fact it could also be an ostrich because she's only described it as dark green and fairly large. So therefore, Charlotte has made a mistake in assuming that it has to be an emu's. So it can also be an ostrich's. That's the mistake she's made. Okay, moving on to Oliver's statement. Oliver then says, but it's only about 10 centimeters long, so it can't be an emu. That's what he's referring to, right? So he's saying because it's only 10 centimeters long, it can't be an emu. Now, if you look at the statement in the box, it says an emu's egg can measure up to 13 centimeters. So what that means is an egg can have a maximum of 13 centimeters. Doesn't mean it has to be 13 centimeters. It can be anywhere from 1 all the way through to a maximum of 13, right? So what Oliver's saying, with the fact that it's only 10 centimeters, it can definitely still be an emu's, right? According to what we know to be true, the emu's egg just can only be a maximum of 13 centimeters. So again, Oliver's statement is incorrect in this scenario. He has assumed just because it's 10 centimeters, it can't be an emu's, whereas in fact we know that an emu's egg just has to have a maximum of 13, right? It can be somewhere below that as well. So therefore, in this case, we have to choose option D, neither Charlotte nor Oliver. Okay. Excellent. Let's move on to question 13. Let's have a read of it. It says a piece of string is initially held end to end in a straight line. A mark is made in the middle of the string. Okay. The string is then folded in half and the new ends again pulled tight. A mark is made in the middle of the strands of the folded string. This process is then repeated a third time. The string is then unfolded and its ends pulled so that once again it's in its initial straight line. The distance between marks on the string is found to be 4 centimeters. How long is a piece of string? Okay, so it's a bit of a tricky question. It's problem solving with some visual spatial reasoning, but majorly problem solving. Okay, and as you can see, the question is quite long. And whenever there's a lot of information in a question, it's always a good idea to consider to drawing a diagram, because diagrams are able to summarize or synthesize a lot of information into one picture, which is much easier to deal with. And that's what we're going to do for this question, right? That's the method of approach. So let's draw out our piece of string. I'm going to underline the question as we read through it. So a piece of string is initially held end to end in a straight line. So let's do that. So you got a piece of string, goes from there to there. And then a mark's made in the middle of the string. Let's make that a red mark. Okay, so red mark. We'll make it in the middle, like here. And then we know that the string is folded in half and the ends again pulled tight. So we're going to fold that in half. So it's going to go on top of each other. So just imagine me bringing, let's say this end A and this is end B. Imagine me folding end B on top of end A. Okay, so it's going to look like A/B here now. And the piece of string is just going to be like there. Okay, and that red mark, keep in mind, is still going to be here, right? Because all you've done is fold B over the top of A. Now let's keep on going. It says a mark is made in the middle of the strands of the folded string. Let's make it a yellow mark this time, okay? So we're making another mark in the middle of this folded string, so right here. And then this process is then repeated a third time. So we're going to fold it and then make another mark, okay? So let's fold it. And now it's going to look like this. So once we fold it in half again, the string is just going to be this long. The red mark is now going to be over here. And the yellow mark is going to stay here. Okay. And now we're going to repeat the process a third time. So we're going to mark the middle again, make that green this time. Okay. And then they're just going to fold it in half. Okay. But then after you fold it in half, you're gonna, and then it says the string is then unfolded, right? So pretty much at this point, we're going to start unfolding this, okay? So let's unfold it once, okay? Now, again, it just requires a little bit of visual spatial reasoning. Imagine me, when I unfold this string about the yellow line, think of it like a mirror image, right? The red dot is then going to get mirrored across to the right hand side. So it's going to look something like this, okay? So there it is. And then we're going to unfold it to the other side like so. The yellow mark is still in the middle here, okay? But now the green mark was here, but it's also gotten unfolded. So think of it like a mirror image, right? Pretend there's a mirror on the yellow line. There's going to now be a green mark on this side after you unfold it. And a similar thing happens for the red mark. So it was originally here, but if you unfold this piece of string, it's also going to be on that end there. Okay. And then we're going to unfold it one more time to its full length, right? Because we're right now at half length. We need to be all the way from A to B here, right? That's the entire length of it. So now imagine there's a mirror at the red mark as we unfold this half of the string. So this is half of the string, and then we're unfolding it across to the other half. Okay, so again, the red mark's here. Now the red mark over the end at the left-hand side of the string will now be mirrored across to the right-hand side, so it'll be there, right, as you unfold it. And we're going to repeat the same thing for the yellow. So the yellow was originally here, and imagine the mirror image as it gets unfolded, it'll now be here. And the same thing for the green. So the greens were originally here and here, and when you unfold it, it's going to be over here and over here. All right, and now we've got our full length of string again. All right, and we're very close to finishing the question. So we know that the distance here, this part here, the distance between marks in the string is 4 centimeters. So that's 4 here, 4 there, 4 there, 4, 4, 4, 4, and 4. So how many lots of 4 is that? Well, that's 8 lots of 4, which is 32. And therefore, our answer is going to be D. Okay, so can you see, imagine doing this question in your head. It's going to be quite difficult. What you should be doing when you have a lot of information in a certain question is to try the strategy of drawing the diagram. I can't emphasize that enough, guys. All right, drawing a diagram, although it takes some time to draw a diagram, it is the often in the test, it's the most accurate and the fastest way of reaching the solution, so you end up saving time. Okay, excellent. Let's move on to the next question. All right, so question 14. Miss Hughes says that I know that 10 of the children in my class are short-sighted, but I only saw 7 wearing glasses this morning. Some of the class must have been wearing contact lenses. Which of the following sentences shows the mistake Miss Hughes has made? Okay, so let's analyze Miss Hughes' statement. She says that 10 of the children are short-sighted, but she only saw 7 wearing glasses. So she has now made this conclusion that some of the class must have been wearing contact lenses. Well, the other 3 students, right? So the problem with Miss Hughes's conclusion is that she's made some assumptions. Well, first of all, she's assumed that if you're short-sighted, you have to either wear glasses or contact lenses, right? She's made the assumption that, okay, I know that 10 of my children are short-sighted. I see 7 wearing glasses. That means the other 3 must have been wearing contact lenses. But couldn't there be a scenario where someone's short-sighted and it's not that bad, right? They don't need to wear a contact lens. They don't need to wear a glass. They might just, they're able to see the board despite being a little bit short-sighted, right? That's definitely a scenario that could be happening, right? And that's the assumption that Mrs. Hughes has made, right? She's assumed that if you're short-sighted, you have to either be wearing glasses or contact lenses, right? And so if we look through our options, which option kind of says what I just try to explain? Well, that looks like option C, which says that some of the short-sighted children might not have been wearing glasses or contact lenses. All right, and that's really the assumption that Miss Hughes has made in this question. Excellent. All right, let's keep on going. Question 15. All right, question 15. in question 15, we have Jess, Camilla, Lucy, and Max are seated around a table on a train. Two of them are facing forwards in the direction of travel, and two are facing backwards. Two have window seats, and the other two have aisle seats. And then they give us information, rules about the seating arrangements. Remember how I said earlier, there's a lot of questions about, the arrangements of people in a line, in a queue. Well, this is also common. Sometimes you might have to arrange people around the table. Okay, and again, the quickest way of doing these types of problem-solving questions is, you guessed it, to draw a diagram. All right, so that's exactly what we're gonna do. So I'm gonna attempt to draw a train here. So bear with me. Okay, it's not gonna be a great train, but you'll get the idea, hopefully. So this is the nose of the train. Okay, and the train's going in that direction. Here we have a table. Okay, and I'm just going to make the seats very obvious. So I'm going to draw them as triangles. So these seats are facing forwards in the direction the train is traveling. And these seats are facing backwards in opposite to the direction the train's traveling. And let's call these the window seats. And these are the aisle ones. Okay. And for the purpose of this question, I'm actually going to draw it twice to illustrate a certain point. So just bear with me. Okay. Awesome. Okay. So now that we've got our diagrams ready, let's quickly read through our rules. We know that Jess is sitting diagonally opposite to Lucy. Max is facing forwards. Camilla is next to Jess. Okay. So the two really important statements are this one here and this one here. The last one says Camilla is sitting next to Jess. So if Camilla and Jess are sitting next to each other, that means opposite to them, Max plus Lucy must be sitting next to each other, right? There's no other scenario where that's possible, okay? And now we also know that Max has to face forwards, okay? But they don't tell us whether Max is on the window seat or the aisle seat. So that's why I had to draw two scenarios to show you, okay? So let's consider scenario one. Max is facing forwards and he's in the window seat. So we're going to write Max right here. Then we know that Max and Lucy are next to each other. So Lucy must be sitting next to him, like so. And then we can use that first statement. We know that Jess is sitting diagonally opposite to Lucy. So Jess must be sitting here diagonally opposite. And we know that Camilla is sitting next to Jess, right, from the statement 3 here. Okay, so that's one scenario. Second scenario is where Max is facing forwards, but he's in the aisle seat, right? So let's do that in red. So Max, M for Max. Again, Lucy is going to be sitting next to him. And then diagonally opposite to Lucy is Jess. And then Camilla is sitting next to Jess, like so. Okay, so that's pretty much the two scenarios that could happen based on the information or the rules that are given. So now let's read through our statements and see which one is true according to our diagrams. So A says, Lucy is traveling backwards. Well, that is not true, right? In both cases, Lucy is facing forwards in both scenarios. So we know that Lucy is definitely traveling forwards. So we can cross that out. Then B, Lucy has a window seat. Well, if you look at our scenarios, in the first scenario, Lucy has an aisle seat. In the second scenario, Lucy has a window seat. So we don't know for sure whether Lucy has a window seat. So we can't accept B as the answer because we need to choose an option that's absolutely true. So although B might be true, it's not must be true. So that's why we can't choose. Then C, Camilla has an aisle seat. Again, in scenario 1, Camilla, she does have an aisle seat. In scenario 2, Camilla has a window seat. So it's a very similar situation to B. We can't accept it because it's only to be half true. We don't know if it's certainly true. Okay, which brings us to the last option. Jess is sitting opposite Max. Okay, well, this is the last option, so it's got to be true. Let's just confirm it. Jess is sitting opposite to Max, so Jess is here in scenario 1, sitting opposite to Max. That's very good. And then in scenario 2, Jess is over here, and she is indeed sitting opposite to Max. So it's true in both scenarios, so it's certainly true. Therefore, D is our answer. Excellent. We'll now move on to question 16. Okay, so let's go down to question 16. So for this one, we'll just zoom out a tiny bit. There we go. Question 16 says, the diagram shows one of a number of ways that 5 different shapes can be arranged together to form a square. Which one of the following squares consists of the 5 same shapes as the square above? They may be turned over. That's quite important. So we know they can be turned over as in flipped up, flipped down, flipped to the left, flipped to the right, okay? So there can be a lot of flipping, or what we also know as reflecting. Reflection, okay. Now, this is an example of a visual spatial reasoning question. Okay. So again, it's really testing whether you're able to move shapes about in your head, right? Both 2D in this case, or 3D in the previous question with the net diagram of the cube. So a quick way of doing this, or just making sure that you're doing things in a very systematic way, is to label the different shapes. And so that's what we're going to do. We'll label this one 1, that's 2, that's 3, that's 4, and that's 5, okay? And then you simply go through the options one at a time, A, B, C, and D, and then you see whether these 5 different shapes are able to be, moved, like rotated, flipped, or reflected to become in the new position in one of the answer options, okay? So I'll show an example. With option A, you start off with option A, right? So looking for shape 1, you can see that it's still here. It's simply shape 1 has been rotated around to make the shape in the new position there. Then you look at option 2, that's shape 2, sorry. Shape 2 is the exact same, so I can just label it there. Okay, shape 3. Again, shape 3, it's possible what you had to do was flip it, then rotate it, right? So if you flip this one across a vertical mirror, right, it's going to look like this. And then if you simply rotate this one this way, you'll make the new position of that shape. So 3 is there. Okay, 4 is the same right here. The only issue is 5. So in 5, you can see that it's kind of a S sort of shape. The one with one end being much longer than the other end. Okay. Now, if you look at this new shape here in A, it's not that shape, right? It's not something that you could flip, turn, or reflect to make. It's actually a completely different shape. And so therefore, we can't make this one, which means we can't make A, and A can't be our answer, right? So you simply repeat that for B, C, and D until you find one that actually matches up to all 5 shapes of the original square, right? So I just point you in the direction of D. In D, you can see shape 1 is simply just here. Okay, it's just been reflected across a vertical mirror. Shape 2, it's over here, and again, it's simply being reflected across a diagonal mirror, right? So if you had a diagonal mirror across here and you flipped it from that way, you'd get this new image, okay? Then shape 3, you can see it's simply been rotated 180 degrees. So it's still there. So, to make sure it all makes sense, it's simply this one rotated around so that it now looks like this. Okay, so that's shape 3. Shape 4, it's the L-shaped one that's simply just been rotated clockwise 90 degrees. Okay, and then shape 5, you can see that it's just been flipped across the vertical mirror to make this new one here. Okay, so that's why answer is D. Alrighty, let's move on to question 17. So in question 17, it says, an environmentalist says plastic pollution in our oceans is not just a problem for the creatures that live there, it affects us too, right? So which of the following statements, if true, best supports the environmentalist's claim? Okay, so remember, for this type of critical thinking question, especially assessing the impact of additional evidence, you need to first figure out what the paragraph is trying to argue. Well, in this case, it's basically trying to say that plastic pollution affects both creatures as well as us humans. Okay, so we should be thinking of looking for a statement that says, hey, plastic pollution is also impacting human lives, right? Not just creatures. So we should be looking for a statement that will describe or say that plastics is affecting the quality of human life. Okay, so you just read through all the options again. Option A says only a small proportion of plastics is recycled. Sure, that might be true. It's not really relevant to the argument, which is trying to say that plastics affects humans too, right? So I might just write that here. Plastics affects humans too. Okay, so I will cross out A because it's quite irrelevant to our argument. Although it may be a true statement, it's not very relevant to our argument. Option B, many things made of plastic could be made from environmentally friendly alternatives. Well, again, that is probably a true statement, right? A lot of things could be made from more better options, like environmentally friendly options, other than plastic. But it's not really supporting the fact that plastics affects humans too. So again, I crossed out because it's quite irrelevant. So remember, it's irrelevant to our argument. C, plastics are durable and can last for over 500 years. Now, this one is saying, okay, plastics, they're very hard to break down. Durable means lasting a long while and, it lasts over 500 years. Now, if you have plastics lying around for 500 years, I guess you could make a case that it would affect humans eventually, but it's not really supporting the specific argument that plastics is affecting humans. Not really a mention of humans being affected there yet. So I still cross it out. I might consider it like a weak support. It's very weakly supporting it. There's not much of a link to our argument, which really leaves us with option D. And D says, plastics have been found in fish, sold in supermarkets. And I'll underline supermarkets because supermarkets are a human construct, right? They're made for humans to buy groceries and fish in, and there is that link to how it's affecting humans, right? Because supermarkets is that link to humans. So therefore, D is going to be our best answer here, since it's actually saying that the plastics can affect what we eat, right? And what we find, the fish that we find in supermarkets. Excellent. Let's keep on going to question 18. So in question 18, we have another detecting reasoning errors question. These ones you can see are quite striking. There's always that box which contains that law or that truthful statement that we can only assume to be true and nothing else. Okay, and then we have to assess Yuri and Bindi whether they have any flaws in their reasoning. So detecting reasoning errors. Okay, let's give it a go. So in the box, it says, when the fire alarm goes off, it could either be a real fire or it could be a fire drill. Fire drills can be scheduled for any day of the week, but they always, just quickly underline that, happen at exactly 2 o'clock in the afternoon. Notice how I just underline words like always, because these are always, these are very strong words, right? It's like must, it's like will. They come with the connotation of 100% certainty, right? And here's a little trick, guys. Whenever you use a very strong absolute word, that's often where you make an assumption, or often that's where the logical reasoning has a mistake, right? There's a reasoning error, because in the world that we live in, there's always an exception to rules, right? You find that, just for example, with certain words like receive, deceive, the rule that I before E except after C. Now that applies to, say, the majority of words, 90% of words, but there's always going to be an exception, that small 10%, where that doesn't happen, right? And same situation for these types of questions. So you should, as a tip, guys, as an alpha tip, you should be very aware of strong absolute words, because that's often where the logical reasoning has a mistake, right? Or there's an assumption being made. So look out for strong absolute words such as will, must, and always. This is often where an assumption has been made. Okay, all right. So let's now go on to Yuri's statement. Or actually, what we could do is, even for this this question, you can draw a little diagram, like a flow chart that helps you just helps you break down the true statement, right? So we know that if the fire alarm goes off, so it's on, could be two scenarios. One, it's a real fire, and that could occur anytime. Or it could be a fire drill. Now, if it's a fire drill, we know from the true statement in the box, it's always going to, so always 100%, going to be at 2 o'clock in the afternoon, right? So it's going to be at 2 p.m. So if the fire alarm goes off, we know that if it's any other time, it's going to be a real fire. If it's at 2 p.m., there's a very good chance it's a fire drill. Of course, it could be a real fire still, right? It could just be a freak coincidence that at 2 p.m. a real fire occurred, and it's not a fire drill this time, it's a real fire. Okay, so now that we have a very clear picture of what the true statement is by doing this flowchart, we can now assess Yuri and Bindi's statement for their reasoning. So Yuri says, if the fire alarm goes off during the morning, it must be a real fire. So that means it's 100% a real fire. Now, if you look at our flowchart, it says, apart from 2 p.m., any other time the fire alarm goes off, then it's got to be a real fire because the fire drill only occurs at 2 p.m., right? So if that fire alarm goes off in the morning, you know 100% that's going to be a real fire, yeah? So Yuri's statement, this time the reasoning is correct, right? It's sound. Now let's move on to Bindi's statement. Bindi says, even if the fire alarm is not going off, it doesn't mean that there isn't a fire. So what Bindi is saying, if the fire alarm is off, right? So I guess fire alarm off, right? It's not going, I guess it's a bit confusing when I say off, but when I say off, I mean when the fire alarm is not ringing, right? That doesn't necessarily mean there's no fire. There's a possibility that the fire alarm is faulty or it's not working, right? And there could be a real fire happening and the fire alarm's not working. Since it's not working, it's not actually going to ring and it's not going to go off, right? So Bindi's statement also logically makes sense. Yeah. So both Yuri and Bindi's statement makes sense. So therefore, we have to choose the answer option of C. Awesome. Let's keep on going to question 19. Okay, so question 19 says, at a school, exams are held at the end of each year. A prize is awarded in each subject to the student who has made the biggest improvement in his or her exam marks since the previous year. In year 9, the marks achieved by the 6 students in the mathematics class were as follows, blah, blah, blah. At the end of year 10, their marks were as follows, blah, blah, blah. Each student won the year 10 prize, won the year 10 prize for mathematics. Okay, so this is an example of a problem solving question. And in this type of one, it's actually one known as identifying similarities. Well, it falls underneath that category where they essentially give you information in various formats, in this case, tables, as you can see, right? And then you have to, so one of the information might be represented in a table, one might be represented in a graph, and you have to identify the relationship between the information in the table and the graph, right? You have to look for a pattern or a relationship. In this case, we have to look for a pattern between the information across 2 tables, right? And we have to figure out which students increased their marks the most, so we know who won the prize. So let's do it. So Uma got 84 in year 9. And if we look in year 10, she got 79. So I'm just going to cross them out as I go. So I'm just going to write that as 84 to 79. So she actually decreased by 5 marks, okay? And then we just keep going. Finn originally had 82. He now has a mark of 88. So he's gone up by 6. Lily, originally 75. Well, now she's 86, okay? So Lily's increased her mark by 11. She's in the front right now. Arlo, 73, now 78, plus 5. Leon, 73, and still 73, so no change. So I just go plus 0. And then Sophie, 69 to 78, so that's plus 9. So who's increased their marks the most? That's definitely going to be Lily, because she increased her marks by 11. So therefore our answer is going to be B. Okay, excellent. Let's keep on going. So now let's go to question 20, which says, Arthur, Bilal, Connor, and David play regularly in a sports team. The coach has just told him, if Arthur does not play tomorrow, then Bilal will play. If Arthur does play, then Connor will play in place of David. And then the question is asking us, so if Bilal does not play tomorrow, which of the other 3 will be in the team? Okay. So just testing if you guys have been paying attention. Again, this is a problem-solving type question. They've given us a lot of information, certain rules, right? And then they've given us a certain question, and we have to figure it out. So for this type of question where there's a lot of information, let's try and synthesize it in a diagram. Now, in this case, because there's 2 certain scenarios, it's a good idea to draw what I call a tree diagram to map out the different scenarios. So this is very effective for those questions where there's particular 1 or 2 scenarios that occurs. Okay, so A stands for Arthur. Okay, now Arthur, he can either play or he doesn't play, right? Those are the 2 scenarios. He does not play or he does play. So let's say Arthur plays, tick, and Arthur does not play, so cross play. Yeah. Okay, so if Arthur does not play, we know that Bilal will play. Bilal plays. Cool. Then, if Arthur does play, Connor will play in place of David. So essentially, if Arthur plays, Connor's gonna play in the place of David, right? Plays instead of David. Alrighty, so let's look at our question now over here. It says, if Bilal does not play tomorrow, which of the other 3 will be in team? So first thing you want to do is see which branch are we going to follow. Are we following the first branch? Or are we going to follow the second branch? Okay, so the information given is Bilal does not play. So if Bilal does not play, we can't be going down the second branch, because in the second branch, if we follow the scenario of the second branch, Bilal plays, right? So we know that Bilal does not play, so we can't be following the second branch. What I'm going to do is just kind of cross it out. Okay, it means that we must be following the first scenario, the first branch. And in the first scenario, who's going to be playing on the team? Well, we know that Arthur is going to be playing, so Arthur's going to be on the team. And we know that Connor plays instead of David, so Connor must also be on the team. So then we look at our options. Which one has Arthur and Connor? Well, that's going to be C, and that's going to be our answer. Excellent. We'll keep on going to question 21 now. All right, so for question 21, we again have an identifying the assumption question. So let's read through it. Faisal says, to have any chance of passing your piano exam, you'll need to practice for at least 15 minutes, 4 times a week. So again, the key word is any chance of passing. You need to practice 15 minutes, 4 times a week. And Sajid says, I practice every day for 20 minutes or more, so I'm sure to pass the exam. And again, I've circled sure because it's one of those very strong, positive, absolute words, right? Which suggests that he's 100% in passing the exam just because he's practiced every day for 20 minutes or more. So which of these sentences shows the mistakes Sajid has made? So it's the discrepancy between Faisal and Sajid's statement. In particular, those two words I've underlined. Faisal says, if you practice 15 minutes 4 times a week, you'll have a chance at passing your exam, right? Any chance suggests anything from 1 to 100%, right? Anywhere between 1 to 100. And then Sajid listens to Faisal's statement, and then he assumes that just because he practices every day, he's going to now have 100% chance to pass the exam. When Faisal has only said, if you practice, every day, or Faisal only says 4 times a week, but Faisal says if you practice 4 times a week, you'll have a chance. But that doesn't mean 100%, right? So it doesn't mean you can say I'm going to be sure to pass the exam. So that's the mistake that Sajid has made. He's assumed that just because you practice every day, you're guaranteed to pass, when in reality, it just means you increase your chance, or you have a better chance of passing the exam. So which answer option best summarizes what I've just said? Well, that would be option D. It says, doing the minimum practice required does not guarantee success in the exam. Right, so that's what Sajid is kind of doing. He's doing the minimum practice. I mean, he's doing a little bit more. He's doing 20 minutes in every day, but still, that doesn't mean you'll be guaranteed 100% success, right? It just means you'll have a decent chance. And then options A, B, and C, after you read through them, they're all quite irrelevant. Okay, excellent. Let's keep on going. Let's now move on to question 22. We'll just have to make it a bit smaller so that we can see it. All right, well, we'll read through the question first. It says, dominoes are to be arranged in a square on a table face up as shown below. New dominoes are placed so that neither of the numbers on them is placed next to the same number on another tile, right? The dominoes numbered 1 to 5 above may be used only once. Which of the 2 domino combinations shown below will not complete the square, right? So if you look at the square, there's 2 domino pieces missing. There's one here. 1 second. There's one over here. And then there's one over here, right? Okay. Now that we know where they are, I'm just going to move it down so that we can see all the answer options. There we go. Okay, so there's many ways of doing this question. One method is just trial and error. You just work your way from option A to option D and see which one would not be able to complete the square. But that takes a bit of time, right? And time is of the essence in exams. So we're all about trying to find the quickest method here. So I'll teach you something. One thing to be aware of is that the tiles can't have the same amount of dots next to each other, right? So if you have a tile with 4 dots, it can't be next to a tile with 4 dots as well. So what I'm going to do is just quickly label the edges here. So we know that this is a tile with 0, tile with 5, tile with 4. And then over here we have a tile with 2, 4, and 2. Okay, so we know that these are the numbers we kind of need to avoid, right, with the remaining options over here. Okay, so I'm quickly just going to write the numbers again. This is 3, 5, 2, 4, 0, 2, 2, 2, 0, 5. Okay, and once you do this, you might be aware of some sort of pattern. The fact that over here, there's 2 2s, okay? which means 2 is a number we definitely kind of want to avoid because no matter where you place this tile here, you're going to have to, you're going to be next to a 2, right? Whether you're in the position 1 here or the position here, if you have a 2, it's not going to work because there's 2s on either side, right? So we kind of know that we want to choose an option that might not work, right? Is something with a lot of 2s in it. Yeah, that's a number we kind of want to avoid. But remember, the question's asking us which one of the following combinations will not complete the square. So we should be looking for an answer option from A to D that contains like a tile with lots of 2s. Well, one that really springs to mind is this one here, right? Domino number 4 has 2 2s, and domino number 3 has a 2 as well. And domino number 2 has a 2 as well, right? So looking through our answer options, which one of these would contain the most amount of 2s? Well, if you look at option C, it's got 3 and 4, right? So if you look at 3 and 4, you're going to have a grand total of, so let me just draw a star next to these ones. You can see that there's a lot of 2s going on there. You're going to have 3 2s and a tile with 0 as well. Okay, so if you think about it, this one has 2 2s. It definitely cannot go in this position here. It can't because regardless of which way you orientate it, it's going to be next to two of the tiles will be the tiles with 2 dots on them will be next to each other, right? Regardless of how you orientate it. So that means this one can only go to the top position. So we can put it here. One sec. All right, so it's not really letting me draw that. So just pretend that this one has to go here, all right? So it has to go there, which means that tile 3 has to come here. And with tile 3, because it has a single, it has a tile with 2 dots on it, it also won't be able to fit in this position here because regardless how you orientate it, it's going to be next to another tile with 2 dots on it. So therefore, our answer has to be 3 and 4. All right, so that gives us an answer of C. Excellent. Let's keep going. Question 23. Question 23 is again a problem-solving / visual spatial reasoning question. So it says there are 6 towns A, B, C, D, E, F in a region. Town B is north of town C and northeast of town A. Town C is north of town D and west of town E. Town F is east of town E. Basically, there's a lot of information there, right? A lot of rules. What you want to do with these questions is the same principle. Draw a diagram. Okay, so what I'll do is let's draw a little compass. Right, we know north is here, south is here, east is over here, and west is over here. All right, and now let's start plotting some of our cities. So we know that town B is north of town C. Okay, so if I just maybe write town C is here, okay, we know that town B is north of that. And we also know that town B is northeast of town E, okay? So northeast is in this sort of direction, right? So if we draw that arrow kind of here, we know that town B, it's northeast of town A, so town A must therefore be here in order to make that true, okay? So I'm just gonna get rid of that to make that diagram look a bit prettier. Then we have town C is north of town D. So town C here has to be above town D to the north. And it's also west of town E. So if town C is west of town E has to kind of be here in order for it to be west. And lastly, town F is east of town E. Right, town F is towards the east of it, so it's in this direction here. So town F must be here. Okay. So now let's look at our question. It's asking us which town is northwest of town D. So what I'll do is I'll circle town D here, and we're looking for a town that's northwest. So northwest is in this direction here. So if I draw the arrow, it's pointing straight at town A. So that means our answer is going to be town A. Excellent. Okay, let's keep on going. Question 24. A politician said in a television interview, the more trade that countries do each other, the better it is for everyone. Which one of these statements, if true, best supports the business's claim? Okay, so again, it's the same question style, assessing the impact of additional evidence. We're looking for one that best supports the politician's claim. And if we were to summarize the politician's claim, or identify the key words, it's saying basically more trade means better things for everyone. Yeah. So more trade between countries is the better it is for everyone. Okay. So trade between countries will benefit everybody. If I had to summarize it, that's what I would write. Trade between countries. 1 second. I'll just write it below. So trade between different countries will benefit everyone. Okay, so if we want to find a statement that supports this argument or conclusion, we should kind of look for a statement that says, okay, trade gives you these benefits, or trade will help everyone in this sort of aspect. Okay, so we need to find a statement that focuses on the benefits of trade. Oh, sorry about the positioning. Let's just reformat it. Okay, that's good enough. Okay, so we should look through our answer options and see something that comments on how trade will benefit everyone or support that. A says it's important for a country to have strong business. Now, that's a bit of an irrelevant statement, right? It's nothing really about trade. It's just talking about business, right? Trade doesn't necessarily mean business. Trade means like trading minerals, trading oil, trading different resources between countries, right? Like meat, animals, cattle, etc. Right? So A is a bit too specific about business, so it's a bit irrelevant in respect to our politician's claim. B, businesses do better when more people are buying their goods and services. I'm sure that is true. Business is good when you have more customers, but that's not talking about trade between countries. Again, it's a bit too specific and it's a bit irrelevant to our politician's claim. So again, that's irrelevant. Now, C says countries that trade with each other, okay, so that's quite relevant to our claim right now, are less likely to go to war against each other. Now, if you're less likely to go to war, is that a benefit for everyone? I would say so, right? Peace is great for everybody, no matter who you are, right? So C is a very strong candidate for the answer right now. And lastly, D says different countries can sometimes make particular goods more cheaply than others. Now, with option D, it is talking about different countries, but it doesn't really explicitly say the trade between different countries will mean, that you get to buy certain goods at a better price. It hasn't explicitly stated that. It's all it's saying is that different countries make different products. Certain products at a better price than other countries. That's all it's saying, right? It's not really explicitly saying, oh, we should trade between countries because that will help everyone. No. So that's why C in the end is still the best answer, because it's the one that best supports and it's the most direct to the politician's claim. All right. So that's another key thing, guys. When you're looking for the answer option in these types of critical thinking questions, it's also a good idea to look for any keywords between the answer option and the paragraph that's given. The more keywords that are the same, the more likely it's addressing the actual, or the more likely it's supporting, what the given argument is, the paragraph. So look for keywords, similar keywords between answer option and given statement. All right, excellent. Let's move on to question 25. Okay, so question 25 says, Daniel wants to make as many cupcakes as possible from the ingredients he has at home. The recipe to make 8 cupcakes needs 100 grams of flour, 100 grams of sugar, 100 grams of butter, and 2 eggs. At home, he has 600 grams of flour, 500 grams of sugar, 300 grams of butter, and 5 eggs. What is the maximum number of cupcakes Daniel can make? Okay, so for this type of question, it really is just testing your division skills here. So we know for a batch of 8 cupcakes, you need these ingredients, right? 100 grams of flour, sugar, butter, and 2 eggs. So now what you need to do is really find the ingredient he has the least of, right? Because that's the ingredient that will limit you from making more batches. Yeah. So looking at flour, just draw a simple line. You have 100 grams of flour and 600 grams at home. So that means you can make 6 batches, all right, with the flour. With the sugar, he has 5 times the amounts needed. So you can make 5 batches. With the butter, he has 3 times the amount, so you can make 3 batches. And then lastly, with the eggs, he has 2 eggs. 2 eggs is needed to make 8 cupcakes, but he only has 5 eggs at home, right? And that's actually 2.5 times. Okay. So what's the rate limiting ingredient here? It's the eggs, right? He has enough of the other ingredients, but he will run out of eggs after 2.5 batches. So if each batch makes 8 cupcakes and you have 2.5 batches worth of ingredients, the amount of cupcakes you make is 2.5 lots of 8. Okay, so when you're doing this multiplication of numbers and there's a decimal point, I just want you guys to ignore the decimal point for now. 2.5 times 8, you have 5 times 8, that's 40, so 0, the 4 carries over. 2 times 8 is 16. Adding on the 4 gives you 20, so that means, it's 200. And now you put in the decimal point again, so you notice there's 1 decimal point, so that means we just need 1 decimal point here. So the answer is going to be 20 cupcakes, giving us an answer C. Excellent. So we're now going to move on to question 26. Okay, so for question 26, again, it's a detecting reasoning error question. So let's go through it. In the box, we know it's true that whenever Mr. Rudd's favorite team loses, it always puts him in a bad mood. And when Mr. Rudd is in a bad mood, he always gives us extra homework. Okay, so if we were to summarize that in a flowchart, that's another tip I have for you guys, is to summarize the information in a flowchart. So sometimes it's just a bit easier to visualize and understand what's going on. So when we have Mr. Rudd's favorite team losing, so losing leads to him, and it's always, right? So 100% of the time, it gets into a bad mood. And if he's in a bad mood, he always, so 100% of the time, gives extra homework. Okay, so we know that this sort of losing favorite team losing will result in a bad mood, which results in extra homework. So this forward flowchart is always going to be true. Okay, so we know when Mr. Rudd's favorite team loses, we can confidently say he'll always give extra homework. Okay, so now let's evaluate the statements. Wei says, we got extra homework last week. Mr. Rudd's team must have lost, must implying 100%. Now, this is a very common trap for students to make. So everyone just pay extra attention here. Okay, so just because we have deduced that when his team loses, he will give extra homework, right? So this forward logic is true, does not mean the backwards logic is also true. Okay, so backward logic. This is not always true. I'm going to draw a big cross here, right? So because we said Mr. Rudd's favorite team loses leads to extra homework, does not mean if he had extra homework, that must have meant his team lost. That backward logic is not guaranteed. Okay, I give you a reason or example why. You might have gotten extra homework last week because of another reason. His cat might have died, or his something else bad happened to him that put him in a bad mood. It didn't necessarily have to be because his team lost, right? So this is a very important learning point for everyone. Just because the forward logic is true does not mean the backward logic is also true, okay? So to summarize, if A leads to B, does not mean B can lead to A, okay? Or it does not mean that B occurred because of A. So yes, this loop of logic does not always occur. Forward does not lead to backward, okay? So not true. Right, you can't assume this circle of logic to be true every time. So Wei's statement is actually incorrect, okay? So then we have Dylan, who says, if they lose this week, we're sure to get extra homework again. See, Dylan is using the forward logic. He's saying that losing will result in extra homework, which is definitely true, okay? So therefore, in this case, the answer must be B, and Dylan's the only one with the correct reasoning. All right, excellent. Let's move on to question 27. Okay, in question 27, we have 3 balls, each of which is either red or yellow, right? And they lie in a straight line on the pool table. Aziz strikes the first ball, which is red. That ball hits the middle ball, and then the middle ball hits the last ball, which is yellow. Okay. On the basis of this information, which one of the following statements must be true? Okay, so again, it's a problem-solving question. You have 2 scenarios. You don't know what this middle ball is. You don't know whether it's red or whether it's yellow. So 2 different scenarios. hopefully that triggers something. You remember from what I taught you before, if you have two different scenarios, it's always a good idea to draw a tree diagram. And that's what we're going to do here. Okay, so we have the first ball, the second ball, and the third ball. Now we know the first ball is red, so I'm going to make that red. And we know the second ball is yellow, we know the third ball is yellow, so let's make that yellow. Now, in between, we don't know whether the second or the middle ball is red or it's yellow, so let's see what happens in both situations, okay? So, could be red, so let's say the first branch it's a red ball, and then like so. Or it can be the second scenario where the middle ball is yellow, and it's going to be that scenario. Okay, now let's read through our options and see which one would be true according to our tree diagram. A says only one of the balls was red. Well, that would only be true in the second scenario, but in the first scenario you can see there's two red balls, so option A, it might be true, but it's not a must be true. So again, we will have to cross it out because of that. Option B says a red ball hit a yellow ball. Well, if I point your attention to the first scenario, a red ball hits a red, and then the red ball hits a yellow. So a red ball does indeed hit a yellow in the first scenario. In the second scenario, the red ball hits a yellow ball. So I'll stop right there. You can see that in both scenarios, a red ball does indeed hit a yellow ball. It's true for both scenarios, so it must be true. So, already I would say confidently that B is the answer, but you just need to cross out C and D as well. So in C, a yellow ball hit a red ball. If you look at our diagram, that's never the case. No yellow ball ever hits a red ball, so C is incorrect. And lastly, D, only one of the balls was yellow. Again, that only occurs in the first scenario. In the second scenario, you can see there's two yellow balls, so that's not always going to be correct. That leaves us with the answer of B. Okay, let's keep on going. Question 28. All right, so for question 28, it's a visual spatial reasoning question again, okay? Now, this one has a very efficient way of doing it. So let's have a look at it. A view of a single view, a level, of a building is shown below. Which one of the following drawings represents the floor plan for this level of the building? All right, so you're looking at a 3D image and you have to translate it into a 2D image, right? So it goes from 3D into 2D. Okay, or essentially what you're doing is a bird's eye view. So imagine you're looking from the top over this over this building, and you have to now visualize what the floor plan might look like. So when you do this sort of question, you want to look out for distinct patterns and shapes. And the one that really stands out to me is this little square here, as well as the rectangle that's right next to it. It's quite distinctive, right? Every other shape is quite complicated, but I know that there should be a square and a rectangle right next to each other, right? So we really should be looking for a square plus rectangle combo in one of our answer options. So now if we go down, okay. All right, so I'll just get rid of this stuff. Okay, looking at A, B, C, and D, which one do you notice would have a square and rectangle next to each other? Well, there's only one option really. It's option D. Can you see the square here? And then the rectangle right next to it? Every other option doesn't have that combination. So you can confidently say that D is the answer just because you looked for a distinct pattern of shapes. And that will definitely be the quickest way of doing this question. Awesome. Let's move on to question 29. So in question 29, we have again one of those problem-solving questions where there's a positioning of chests next to each other and there's certain rules, right? So same thing. We're always going to attempt this type of question with a diagram. Okay, so let's read it first. A girl is locked in the dungeon of a castle. There are 5 chests in a row in the dungeon, one of which contains a key to escape, but the others contain poisonous snakes. The girl can only open one chest. She has 5 clues to help her make the choice, and those clues are below. Okay, we'll go through them shortly. What I'll do now is start drawing the diagram. Okay, so we're gonna have 5 different chests in a row. So we'll make this the left hand side. We'll make that the right hand side. And we got 1, 2, 3, 4, and 5 chests here. Okay, so what I will usually do with regards to the rules, I read through them and I add to the diagram when I'm sure. Okay, so we read through the first clue. It says the white chest is 2 places away from the chest with the key. Now that's a bit too vague. Like it could literally be anywhere. The right chest could be in position 3, could be in position 2, 4, and 5, and 1. I have no clue where it could be, so I can't really add that piece of information to the diagram yet. So I'm just gonna hold that for now. Okay, let's keep on going. Then it says the black chest is at the far right. See, that's very specific. I can actually put that on our diagram. We know it's on the far right, so it has to be in position 5. So black. All right, maybe a better idea is to do it in black. So let's do that. Okay, so we know it's on the far right, and it's 2 places away from the white chest. So the white chest is 2 places away from the black one. I don't unfortunately have white color, so we're gonna have to do with just the red marker. Well, if 2 places away, it can only be in one position, and that's in position 3, 2 away from 5. Okay, so we've used this piece of information, so I'd just like to make a mark that I've used that piece of information. Then we'll keep on going. The red chest is not next to the chest with the key. Again, this one's a bit vague, right? We don't have enough information to really draw in our diagram, so we keep it for later. I have no idea where the chest with the key is. We have no idea where the red chest is, right? So we really can't put that information in the diagram yet. So we go to the next clue. The yellow chest is to the left of the white one. So that one is a pretty good clue. We know the yellow chest has to be in either position 1 or position 2. So again, don't make the mistake of assuming it's just going to be in position 2 because it says it's to the left. It didn't say immediately on its left, right? So again, I can't use that information right away, but I know the yellow is either at position 1 or 2. Let's see what clue 5 gives us. The purple chest is not next to the black or white chests. Okay, so if you think about it, we know where the white and black ones are. Okay, now it says the purple chest is not next to either one of them. So it can't be in position 4 because it's next to both the white one and the black one. Can't be in position 2 either because then it would be next to the white one. So that means the purple one has to be here in position 1. Okay, and remember what we were talking about before. In clue 4, it says the yellow chest is to the left of the white one. Well, now, since position 1 is taken, we know that the yellow chest must therefore be here. And then just filling in the blank, we know the right one must be in position 4. Cool. So now we know the colors and where they are. We still have to figure out where the actual key is, right? So we read through our information. So we know that from the clue number 1, the white chest is 2 places away from the chest with the key. So the white chest is right in position 3. So 2 places away is the chest with the key, right? So it could be in chest number 1, the purple one, or it could be in chest number 5, the black one, right? So I'm going to circle both of them. These are both our potential answers. Now we need to use the last clue, which is that the red chest is not next to the chest with the key. The red chest is here, and it's not next to the chest with the key. So that means black can't have the key since red can't be next to the chest with the key. Therefore, our answer has to be this one right here, which is chest number 1 or the purple one. So, therefore, our answer is D. Excellent. Now let's move on to the last question, question 30. So in question 30, we have Zara's class wanted to decide what color to paint their classroom. They decided to have a vote. Students could vote to change it to red, yellow, or green. Everyone had to cast 2 votes, but could not vote for the same color twice, so they had to vote for 2 different colors out of the 3. The color would only be changed if everyone voted for the same color. That's pretty important, okay? So the color is only going to change if everyone votes for the same color. If this did not happen, the room would be left unpainted. Every color got at least 1 vote. Knowing one of the following would allow us to know the results of the vote. Which one is it? Okay, so this is one of those problem-solving questions. So essentially, the way I would approach it is just run through the answer options. So it's an elimination approach. And the reason that you have to do an elimination approach is because you only know if the answer is correct or not is by actually testing it out, right? So it's given the nature of what the question is asking us, okay? So we go through option A first, okay? It says, no student voted for both red and green. Now let's think about the connotations of that. If no student votes for both red and green, that means they must have voted for yellow, correct? Because you have to vote for 2 colors, right? Everyone has to cast 2 votes and it has to be different colors. So that means every student, if I had to write out red, yellow, and green right now, that means every student had to have voted for either red and yellow or yellow and green, because they could not have voted for just red and green. So let's pretend these are the students and we'll just keep continuing, right? The only combinations of voting that they could do is red, yellow, or yellow, green, since they can't vote for just red and green themselves, all right? So as you can see with the pattern that's developing, this means that yellow is voted every single time by each student. And do you know what happens? According to the question, if one color, if everyone voted for the same color, then the room would change to that color. Well, in this current scenario with option A, we can definitely say that yellow is going to be voted every time, and therefore we would know the results, right? And that is that the room would change to the yellow color. So based on this, I would say the answer is A, but you should just be careful and eliminate the other options, okay? So in B, it says every student voted for either green or yellow or both. So it's saying basically, if I drew another one of these red, yellow, green ones, every student either they voted for the green option or they voted for a yellow option or they did both, right? So one student might have just gone for straight for green and yellow. One student might have voted for yellow and red. One student might have voted for green plus red, right? But as you can see, based on what B is telling us, the students are able to vote for any color, okay? And we really don't know whether one of the colors will be voted the entire time, right? And so you won't know the results of the vote, right? You won't know whether red, yellow, or green will become the most popular vote or like will be voted every time, right? So in that case, we now know that B, we won't be able to decide, we won't be able to know the results of the vote. Now, C says red was the most popular vote. Again, this is not enough information. Telling me red is the most popular vote doesn't tell me whether it was voted, whether everyone voted for it, right? Most popular might be that out of 30 students, 29 students voted for it, right? In which case, the room won't actually change to red because not every single kid voted for red. So with C, it's too vague. Most popular doesn't tell me whether everybody voted for that color, and therefore I won't know the results of that vote. So therefore C is again incorrect. And then D tells me only two people voted for green, which again is not enough information. I have no idea about who voted for red, who voted for yellow. So we have no clue whether red was the dominant color or whether yellow was the dominant color. Okay, so D again, insufficient information. Only A is the one that clearly can tell us that yellow was voted every single time by each student, and therefore we know the results of the vote. All right, guys, that brings us to the end of the thinking skills paper. I hope you guys found it useful, especially with not just the explanation of how to arrive at the answer, but also the different tips and tricks with approaching the different types of thinking skills questions. And I do hope you guys enjoyed it. Thank you very much.